So that's a good example of chert.
That's flint.
Flint.
Which is, chert is sort of a catch-all for anything that's.
Okay, so flint is a subcategory of chert.
It's just another name for
Another name for it. Okay.
But a specialized kind. Usually, flint is usually something that's gray or even black.
They're going to start calling it the Chert Hills.
It's nice and dense, and it has what we call conchoidal fracture. I mean, you could hit that with something, and it shears off into the irregular little slivers.
We're curious, when does it change from mudstone to shale?
Well, I was just going to say, that's getting pretty close.
That's what we're...
You still break it. Somewhat.
Chemically, are they the same?
I always do.
Well, it depends on the shape. Well, usually the shales
Breaking down. It's
around here are going to be black or dark colored.
didn't have enough
But
pressure on it.
you could call that a shale, all right.
And what's the progression again between turning from mudstone to shale?
Well, this would probably be the intermediate.
Okay, it's at a...
You do. It does break up in flakes. Well, it's not so much
moisture
chemically.
also.
It may be a little bit of composition involved.
More structural.
More how it got
Yeah.
laid
Well, I took this from the very top layer, like
Yeah.
way over there. There's several of them.
Yeah, I'm sure.
But this has got enough
Wouldn't this
cover-
be a pressure partly related?
Partly, yeah, sure.
They always say drier,
Yeah.
too.
Where that came from? Did you get that? Was
Just
it in,
washed down
was
there
it in
in there.
position?
Sure has my calcium.
Limestone. Technically. But it's got some mud in it. If you were to dissolve all of that in acid, you'd get some mud left behind, which is not soluble.
So
or not
what's
very
this
soluble.
darker striation here?
Well, you can see. It could have been an organic. It's just an impurity of some kind.
Wasn't real hard though, was it? It broke. I mean,
Well, it's brittle.
yeah.
We're seeing fossils, shell fossils in the limestone.
Yeah, those are the real brachiopods.
I know they're brachiopods, but
Well, it's,
There's a lizard underneath here. Right here.
was. Yeah,
Wow, look
it's a
at
nice
that.
little
Yeah, that's a good
brachipod.
Is that cool or what? Look at that.
Beg your pardon?
Boy, the grasshoppers.
Look at that. Oh, wow, look at that.
well, I don't know where that guy came from.
Gee, man. That's got a little bit of everything in it.
Yeah,
Right?
well, that's a,
Beauty.
That's
a
at
big
that.
chunk of, that's
I
all,
don't usually see them like that.
it's all silica. They're all flint quartz, except these part right in here, which is dissolved away. I don't know where that came from.
Look at that. Isn't that neat?
What do you got there? Grasses? What are these?
The orange is a mix of iron and what did you say?
Well, I think maybe calcium carbonate. I don't know.
Doing these days. Still? I think I started that already.
Fossils
Shell.
and flint.
Yeah, that's a nice, right there, bivalve.
What's this right there? Is that different color there?
Yeah, it looks like kind of mud. It's mixed in with the So I think that's
Yes.
it's just in chunks. Probably a pretty shallow marine environment, and with enough mud on the bottom, and when the storm waves came in, they probably broke off chunks and rounded them and so forth, and then it gets incorporated in.
Looks like
with
something
rock,
indented here.
Yep, that's the cross section. If you cut that
I see.
the side beam, you can actually see some of the ribs that are showing.
And then is that a leaf?
I don't think we'd find any leaves. I think that's just a fracture. Maybe they are very thin
Thin shelled.
shelled.
No leaves, no grasses at that period of time.
No. Grasses didn't start until about the Miocene to August.
And what date do they get to Tell me your
30 million years. Pretty young.
This is a panoramic shot that shows the shale and limestone layers. This is the 3 Mile limestone layer. There's a lot of chert, a lot of flint in it.
I got you. Is there a cause for it to be more blocky? Instead of globular, it's more blocky.
Look at this one. This is neat.
There's one.
What are there? That's just getting near the upper part, and they get horizontal season all the way around here, and then much more massive. But it's close to the surface, and you get a weathering part of patina. Some people use that patina to guess what the age and how old it is. I don't know how they do it. I guess it's by experience. It's archaeological sites. So to figure out how old it is, with patina, how long it's been exposed. That might have been a crinoid columnals.
Could be.
That have been silicified.
So
They look like a old stack of pennies.
Yeah, sure.
They grow up like
Probably better.
plants. I think that's probably what it is.
something that was growing on the bottom of the sea then, or but isn't that odd that it would be down in the chert?
No, because it gets silicified.
What is that?
Well, I think it's a crinoid columnal that's been cut. They form kind of stems and stacked on one another. The Indians used them for necklaces and things like that.
The chert filled in then.
Look at that. That is amazing.
I don't know why it's got that much space in it. You can see what you have to hold it pretty close.
Interesting.
Let me take a look. Get my glasses off here.
Can you turn it, when you're finished, can you turn it this way? So there we go. Okay, good. Thank you.
And then it would be growing up this way. It
It's
would be
growing this way.
Oh.
Well, you're looking at cross section.
Okay.
It's a stem grew up.
And this here looks like the spinal cord right there.
Well, I think that's just the way the replacement took place. You know about plate tectonics and how these continents and land masses have moved around. This is what we think the early Permian, which is a little bit before rocks here, but this is what the world looked at like back 270 million years. Here's the U.S. I plotted up here where we are, or where we are in the U.S.
Tropical.
Yeah.
Subtropical.
But one of the friends I have who works with NASA has been able to trace the part of the things down in here over to the Amazon in Brazil. The bedrock is the same age and the same composition. And what I do point over here, that's Africa. Point down in here. Sorry.
Yeah, there's South America.
Yeah. But and the Gulf of Mexico wasn't there. But that's an idea how things have moved around. Things I played around with is the silica in grasses, and got onto this simply by accident. We had a dust trapping station that went from Colorado to the East Coast and up into Canada, down into Texas, and we were trying to trace the source of the and the quantity of the amount of dust that's been transported. And when I first looked at the things under the microscope, there were a whole bunch of things I couldn't possibly recognize at all. And we had a German graduate student who's a very interesting guy by the name of Seuss. He came over here and to work on a master's. He'd been in the equivalent of the Peace Corps in Africa, the German Peace Corps. And I got him interested in see if he could find some method of tracing the dust that is picked up in the oceans. We thought probably around Kansas, Colorado, New Mexico, maybe that general area. Well, we eventually found some things, and he found out that there's a difference between the silica bodies in the tall grasses as opposed to the short grasses, prairie, and he was able to identify these. Now, if you look at, but when you look at photomicrographs, people who deal with weeds and seeds, palynologists, they just find spheres like that. They call it grass pollen, but they can't tell the climatic conditions. With these things, you can tell the climatic conditions. These are cool season grasses. These are intermediate tall grass prairie, and this is a short grass prairie. I feel that if you take the ratio of what we call the chlorodoid phytoliths and compare it with the total number of these grass things, you can come out with an aridity index, which works pretty well. Well, there's even a book now on, well, there are 3 or 4 books, but this gives you an idea. This is of what had an international conference in Aix-en-Provence a few years ago, and we had it was kind of started here at K-State with Erwin Seuss and Dick Smith, and I were able to develop the first classification. And now we have the science for phytolithology, and we have I think something like 60 nations represented in now, and that's sort of want to look at that, the different types of people and the different types of things that have been working on the grasses themselves.